Okay, this is day 2. It's not too terribly difficult. It's similar to what we did before where we're taking a situation and putting it in 3 different ways. We have Rachel starts cycling a distance away from her house at a constant rate. The table shows her distance from home, y meters, as a function of the time she takes to cycle, x seconds. So at 0 seconds, when she hasn't gone anywhere, she's 6 meters from home. After 1 second, she's 10 meters from home. After 2 seconds, she's 14 meters from home, and so on and so on. So this is a little different. Before I gave you numbers in the scenario, and now I'm giving you information in a table and expecting you to go different places with it. So the first thing they have us do is graph the function. So you have the points here, and I have them open on my desk. So I'm going to plot the points. Now, I look on here and I see that the numbers go 0, 1, 2, 3, 4, 5 on the x-axis. So time is down here. That's on the x. And this is meters. And since this just goes 0, 1, 2, 3, 4, 5, I'm feeling pretty good about making each one of these worth 1. Now, the other one goes 6, 10, and it goes up to 26. So I don't think I have 26 squares here. So I'm not going to count by ones. Maybe I'll count by 5s. And again, you can pick what you'd like to count by. So each box here I'm going to count as 5. So at time 0, it was 6 seconds. So I'm going to make that just a little above the 5. At time 1, it was 10 seconds. At time 2, after 2 seconds, 14. So just a little bit below because that line would be 15. 3 would be 18. Let's put that right about here. 4 would be 22. And 5 was 26. Okay, so you can graph it. You see it is a linear function as we talked about today. The next question says, write an algebraic equation for the function. You can do this in 2 ways. I'm going to work from the table, and then I'll go back and work from the graph. For the table, this is our y-intercept. Wherever x is 0, that's our y-intercept. So that's our b in y equals mx plus b. To find the slope, we've done this a million times in the last chapter. I'm going to find the difference in the y's. So I did 10 minus 6 over the difference in the x's, 1 minus 0. Again, the difference in the y's goes on top. That gives me my slope of 4 over 1, and that's my m. So when I plug them into y equals mx plus b, I get y equals m, which is 4, x plus b, which we found right here, our y-intercept is 6. Now in the graph, depending on how you did it, you could do that. Here's your y-intercept right here. So again, that's my b, and that's 6. And on the graph, it's a little hard with the way that I did it, the way I made my graph, but you might be able to count if you counted differently. It went up 4 and over 1, so my slope was 4 over 1. So again, the slope can show up in the graph, and the y-intercept can show up in the graph. It can also show up in the table. So our equation was y equals 4x plus 6. Describe how the slope and the y-intercept of the graph are related to the function. So we have y equals 4x plus 6. Now, to explain what those mean, I'm going to type it because it'll look nicer. Okay? Our y-intercept was 6. This means, so this was our y-intercept. Sorry. Our y-intercept is 0, 6, which means 0 seconds, 6 meters. She started 6 meters from her house. Because at time 0, which is when she started, she was 6 meters away. Our slope was 4 over 1. Now, what did you subtract to get the 4? Did you subtract the meters or the seconds? I subtracted the meters on the top and the seconds on the bottom. So this means she travels 4 meters per second. And again, how did I get the 4? I subtracted meters. Look at the numbers you subtracted. What were they standing for, meters or seconds? So when I say describe that, that's what I'm looking for. Okay, for the next example, if you look in your notes, I forgot to put the table into the notes. I apologize. So copy that. You can push pause and copy this table. Once you have the table copied, the next thing I'm going to have you do is I'm going to ask you to follow along your notes, make your graph, your equation, and describe, and push pause while you're doing that. Work it through by yourself. Then push play again and check your answers. So don't follow along and just copy. Push pause now, try to do it by yourself, and then push play to make sure you got it right. All right, so I'm going to graph. And again, I'm going to look at the numbers I had, and you have these written on your, my X's was my gallons, and Y was miles. Okay, the gallons went 0, 1, 2, 3, 4, so I feel pretty good about making each box worth 1 along the x-axis. For my miles, they started at 1,000 and then went up 30 each time. So this is where I'm going to use that squiggle to kind of show, hey, everybody, I'm jumping from 0 to a number. I'm going to use the squiggle. I'm going to make this 1,000, the first line. And then I'll just go up by 30s, just like the numbers did. 1,030, 1,060, and so on. So when I graph, I'm going to go over 0, up 1,000. So there's going to be a point right here. 1 was 1,030. 2 was 1,060. 3, 1,090. 4, 1,120. 5, well, I think it only went up to 4. You can see the graph. So that's the graph using the points from the table. Now the next question says write an algebraic equation. So again, you could do this. I'm going to show you from the table or the graph. You only have to do the one that works for you. So here's my y-intercept. To find your y-intercept, find where the x is 0. That means this is my b. To find my slope, I'm going to find the change in y. And you could pick any 2 points. We've learned about that too. Over the change in x. Notice that I started with 130 on the top, so I need to start with 1 on the bottom. And that gives me a slope of 30 over 1. So I have y equals mx plus b. My m was 30. And my b was 1,000. You also could have found this equation by looking here. Your y-intercept is here at 1,000. And if you did the slope, you would see you went up 30, because remember each box was 30, and over 1. So it was up 30, because each box we made 30, and we went over 1 because each of the boxes this way was 1. So you would get your slope of 30 and your y-intercept of 1,000. You would get the same equation. So again, our equation is y equals 30x plus 1,000. Now to describe, okay, well, let's go back. My y-intercept is 0, 1,000. This means 0 gallons, 1,000 miles. Okay? So 0 gallons, that's when he started, okay, because it was showing his total distance and his odometer, which is keeps the mileage for your car. So when he started, and that's what your y-intercept is always going to be. It's when it started. He had 1,000 miles on his odometer. For our slope, it was 30 over 1. How did you get the 30? Did you subtract miles or gallons? I subtracted miles to get 30, and to get 1, I subtracted gallons. So 30 over 1 means he is getting 30 miles per gallon. And this is similar to what we did before.